Alrighty, so we're going to work through this question here, and this is the question that appeared in your ECP CAT. So think back, this was the question that appeared in part B of your ECP CAT. And the reason why we're going through it again is because it comes up again in this chapter. So it comes up in this chapter, so 5H, but it made its first appearance back in ECP when we were going through exercise 3L. So it's quadratic modeling again. The only difference now is that they're also going to incorporate some function notation in it. It's pretty much identical. There's hardly any difference really between 3L and 5H. There's only very slight differences that I'll talk about, and you can actually just see it right here. The only real difference is that we now can say A of X instead of just saying A, and that's really the only difference. But I thought it would be advantageous for us to work through this CAT question again, because it's really important that you get your head around quadratic modeling, because it's very important, which is evidenced by the fact that it appears in 2 exercises. And there were a good chunk of us who struggled with this. There were some of us who found it fine, because this is an idea that you also went through in Year 10. It appeared in your Year 10 exam, but it's something that just keeps on appearing. I know that people have trouble with it, so I thought, you know what, I'm just going to put the CAT into the notes. We can work through it together, and hopefully you feel good with it. And then you can do 5H for even more practice of it. Okay, so with that preamble, let us dive into this question here. It says, a builder uses 90 meters of timber to make a frame. The shape and dimensions in meters of the frame are shown below. So here is this frame here. Now, the first thing that we have to realize is that this frame uses 90 meters of timber. So therefore, this 90 meters is the perimeter. I dare say that is the most important thing to realize. If you don't realize that, you really can't go any further. And it's just making sure that you read the question carefully to get your head around what it's saying. So we know that the perimeter is 90 meters. So if we add up all of these sides, we're going to get 90 meters. All right, we continue on. It then says, find an expression for y in terms of x. Okay, so what we're going to do is we're going to use our knowledge that the perimeter is 90 meters to help us out here. I can say, all right, I'm going to add up all of these sides, and when I add them all up, it's going to be equal to 90. All right, let's do that. So I've got y plus x plus 2y plus 2x, and then here, what's this one here? This one actually doesn't say what it is, but you can clearly see I've got y, I've got 2y, this is going to be 3y. And then this one here, even though it's not labeled, we can see that I've got x here and 2x here. This is going to be 3x. Now, I know that when I add all these together, it's going to be the perimeter, which is 90. The next thing I would do is just gather together my like terms. So I would gather together all the y's. Y plus 2y plus 3y is 6y, plus x plus 2x plus 3x is 6x. That's equal to 90. Now, when it says find an expression for y in terms of x, it means make y the subject. In other words, get y by itself. So I want to get 6y by itself, so I'm going to minus 6x to both sides. And I now need to get rid of this 6, so I can have the y by itself. So that means I'm going to divide both sides by 6. Whenever you simplify, you must simplify. 90 divided by 6 is 15. 6 divided by 6 is 1, so it's just going to be 15 minus x. That right there is my answer. So as you can see, I found y, so y is the subject, in terms of x. It's in terms of x, meaning x is there. Okay, let's continue going on. And as you can see, that's 1 mark for the answer. Next. Now, this next one is important for us to go through because it is a show that question. So as you can see, it says show that the function that gives the area of the enclosure A in terms of x is given by A of x is equal to 105x minus 7x squared. So as you can really see, the function notation really changes nothing at all. So in your CAT, this just said A was equal to. Now we've just got A of x. So again, this really isn't a new idea that we're going through. I'm mainly just going through this CAT example because so many people had trouble with it. But we've already gone through it in 3L, already 5H, not much different to it. Okay, with that being said, I want to go through what a show that question is telling us. What is a show that question telling us? It's saying that we need to show that this is true. We cannot use this in our working out. We need to arrive at this. So we're going to do a whole bunch of working out, and if we've done it correctly, at the very end, we should get this. You might be asking yourself, what's the point of that? Why have they told me the answer? This kind of a bit redundant, isn't it? But it isn't. And the reason why it isn't is because if you couldn't do this question here, you can continue doing the rest of it. Okay? So if you can't do this question here, because they've told you that A in terms of X is this, then when you come to part C and it asks you to graph A against X, you've got the answer. You know that you're just graphing this right here. So a show that question many times are given so that if you can't do something, you can continue on. And in that first cat, so many of us were like, I can't do this. And then they didn't read this properly. And then they just stopped. You've got to make sure that you're reading the questions carefully. Okay, how are we going to do this? Well, we need to figure out the area of this enclosure. So let's come up here and see if we can figure that out. I'm going to break it up into two parts. The area of this part here will just be x times y, so xy. And then the area of this part here will be 3y times 2x, which is 6xy. So if I add this and this together, I'm going to get the area of the entire thing. So that means the area is xy plus 6xy. Now, it says I need the area in terms of x, not in terms of both x and y. At the moment, I've got it in terms of both x and y. So I need to get rid of this y. How am I going to do that? Well, I'm going to sub in this information here. I'm going to sub in y is equal to 15 minus x. So I'm going to take this and I'm going to put it into the y spots. And I want you to see what happens when we do this. I'm going to end up with a is equal to x, and then instead of y, I'm going to write 15, well, that's not a 15, 15 minus x plus 6x, and then instead of y, 15 minus x. Then, as you can see now, I have a just in terms of x. There are no y's anymore. So the whole point of subbing that in was so that I could get a in terms of x alone. That was the point. All right, now we continue on. I'm not done yet, and I know I'm not done because this, at the moment, doesn't look like this. So hopefully we can get there by just expanding this out. This will be 15x minus x squared plus 6 times 15 is 90x minus 6x squared. We'll then gather our like terms, which is going to leave me with negative 7x squared, and then 90 plus 15 is 105x. And wouldn't you know it, this now is the same as that. So we have done it. So normally what you can write here when you've got to show that question is just say as required. So I've gotten this as required. And the one last thing I would want to add to this is instead of writing a, I can write a in terms of x. And that's where our function notation comes in. But as you can see, did it really change that much of what we're doing? Not really. With this, the reason why this exercise is appearing again is because we want to get you really good at quadratic modeling. Okay, there it is. Perfect. So we've got a in terms of x, there's our answer, just as it is there. If you've got to show that question, you cannot use this in your working out. It needs to appear as your answer at the very end. We now continue on. Sketching. Sketching on our CAS. On the set of axes below, sketch the graph of A against X. Indicate clearly on the graph the turning point, the endpoints to 2 decimal places. So let's see if we can do this. I'm going to come over here, and I just need to look at what this is. All right, let's bring this here. I'm going to come here and I'm going to go 105x minus 7x squared, hit enter. Now, on the cat, many people went, oh, what's happening here? I've got a straight line. And they were just very confused because they probably looked at this, saw that I have a square, knew that that's a quadratic and therefore this should be a parabola, and were just very confused as to why they were getting a line. Why is there a line here? Surely it should look like a parabola. It should look like this. Why isn't it looking like that? Well, what you had to do was zoom out. So Windows, zoom, and then there's a couple of different ways to do it. We'll go slowly and I'll talk about the different ways. Sometimes, if you go zoom fit, it will do it nicely for you. This is still a bit cut off, but if you just put your cursor on the white bit and then hold down the center button, it allows you to drag it and you can see, oh yeah, that's a bit better. Another way we could do it. So let's go Control Z. And that will take us back to where we were. Control Z again. It's just like a computer. Another way we could do it is go menu, we could go analyze, and we could, sorry, not analyze, window zoom, and we could just zoom out a bunch of times. Zoom out, whoops. Menu, window zoom, zoom out, zoom out, zoom out, zoom out, zoom out. And then you can kind of see it. And you might say, well, I wanted that to look a bit better. And to do that, we could therefore go window zoom, go zoom box, and then just put a box around this. And then you can see that a bit nicer there. Let's talk about another way we could do it. So you might be thinking, there's a lot of empty space here. How can we fix that up? This is another way to get the zoom correct. We could go menu, we could go window zoom, and then go zoom settings. And now we can put in what the minimum X is. So as you can see, it's currently at -63, which means the X-axis goes to -63 and the maximum X is going to 166. Now we know that this thing is going to start at around 0. So I might just go, -10 this way, and I might go, all right, let's make this 20 that way. And I'll leave that as is because I think the height is pretty good at the moment. We can go okay, and you look at that. That's a bit nicer. So just by approximating the minimum X and maximum X and the minimum Y and maximum Y, we can get it to look a bit better. So there are just a couple of different ways for you to fix your window settings to see what you need to see. And just the more you play around with this, the better sense you get for it. It just comes with practice. The more practice you do of these questions, the better you become. Okay, the other things that we need to do now is go menu. We need to go analyze. We need to find the maximum of this thing because that's going to be my turning point. We need to find the X-Intercepts, which will be found by going 0. And that one looks like it's going through the origin, and we'll just confirm that. It definitely is going through the origin. So now we can come over here, and if I do this, I come all the way here, we can now sketch this thing. So it's going to go up, it's going to go down. And then I'm going to put a circle here, because it says I need to label the endpoints. I need to label the endpoints. And you might be thinking to yourself, well, shouldn't I continue it down? But think about it. Can you have, because my y-axis is the area, can you have negative area? You cannot. That doesn't make any sense. There's no such thing as negative area. Area can only be positive. So that's why you should not have drawn anything here. It should not have been extended downwards. That's wrong. That's why it said label the endpoints. It wanted these to be labeled. Then my turning point is 7.50393.75, making sure to give it 2 decimal places. And there we go. We're all done there. Okay, let's now move on to the next bit. And it says find the area when x is equal to 7 on 2. Now, this is where our function notation actually comes into play. So you don't need function notation to do this, but it makes it a little bit easier. If I now come over here and go control, add doc, add calculator, what I can do is say, well, I know that this has been defined as f of 1. So I can go f of 1 of x like that, and you see how it's already defined for me? So by typing things into the graph page, they are automatically defined. So now if I want to find what happens when x is equal to 7 on 2, I can just chuck 7 on 2 into that, and there it is right there. There's my answer, 1127 on 4. Now that's an exact answer. It says state your answer correct to 1 decimal place. So what I'm going to do is I'm just going to come up, hit enter to bring it back down, then go control, enter, and there's my answer right there, 28.75. Now this question is only worth 1 mark. So we literally just have to write 281 point. Now 1 decimal will be 8 meters squared. 281.8 meters squared. And we're done. Now, when you did this in the ECP, you didn't know about function notation. So you used another method that we showed you. And that method was when you literally typed out this and then went control this such that, and you went x is equal to 7 on 2. That's how you did it back in ECP. But now you have this new skill of function notation, which makes things so much easier. So hopefully you can appreciate how function notation, I mean, it's not significantly easier, but it's a little bit easier. You got to take things as they come, the little wins in life. All right, we continue on to our very last question here. And it says the following. Let's give it a read. Because of a shortage of cement, which will be poured into the frame, the area inside the frame is to be restricted to 213 meters squared. Write down the possible values of x and y, which will fulfill this requirement. State your answer correct to 3 decimal places. So what it's saying to me is that the area has to be equal to 213. I need to solve this for x. To do this, I just come here, I go menu, I go algebra, I go solve. I'm solving for when f of x is equal to 213 for the x values, and that gives it to me as exact values. If I hit control then enter, I get that. So that means I'm going to get x is equal to 2.416 because I'm rounding to 3 decimal places, or x is equal to 12.581. Now, it also says that I need the x and the corresponding y. To find what the corresponding y is going to be, I'm going to be using this little equation here, which tells me that y is equal to 15 minus x. So if I come here now, I can figure out what y is going to be by simply going y is equal to 15 minus 2.416. So I'm just minusing the x from it. And so too over here, y is equal to 15 minus, in this case, 12.581. So all I'm doing is I'm taking the x and I'm plugging it in to find out what my corresponding y is going to be. To do this on our CAS nice and easily, we can just go 15 minus, and then if you go up, you can just highlight what you want. If you hit shift and then just, move this around, you can just highlight what you want. It's important that you don't round until the very end. So you see how I'm including all these decimal places, then hit enter. That's just making sure I get the most accurate answer. So now I come here and I'm going to get, I can't write in the highlighter. That's very silly of me. I'm going to go y is 12.581. And then I'll do the same thing over here. I'm going to go, what am I doing? 15 minus that right there, hit enter, there we go. It's going to be 2.481. So y is equal to 2.419 because I'm rounding to 3 decimal places. Then I did not round this correctly. My apologies, everyone. Hopefully you're thinking to yourself, what are you doing, Mr. S? 2.419, 12.581, 12.581, 2.419. Okay. So our answers, and I'll just highlight our answers here so we're all on the same page. Oops, did I just delete that? Okay. What our answer is going to be, I might just get rid of this line here. Just makes things a little bit more confusing. These are our answers. This is my x. This is the corresponding y. This is the x. This is the corresponding y. That's how you do that question, everyone. Hopefully you found this helpful and just feel a little bit more comfortable. And again, can I just repeat? There's a reason why, this keeps turning up. It appeared in exercise 3L during ECP, and now quadratic modeling is rearing its ugly head once again in 5H. Quadratic modeling is important. So it's important that you go through it and just feel comfortable with doing it. That's why we've spent a bit more time on this, because based on ECP, it's something that we struggle with. So I just wanted to make sure that we give you plenty of practice on it and just be as clear as possible with it. So good luck with your exercise and make sure to reach out if you have any problems.